Alright, next problem. I'm going to go through a couple more and try to talk a little faster, so of course you can pause and you should. So I'm hoping you've tried number 2 by now. Number 2 is the integral of 3 sine 3x minus 1 dx. I can see right here that this part is 1 degree higher than that part, the 3 right there. There are different ways to do this thing, but I think this is kind of the formulaic way I'd like to do it for a while. So this is going to be my u. And I get u equals 3x minus 1. So du equals 3. I'm still going to write it as this for now, but eventually I'm just going to write the dx on the other side because I always move it over. So I have that. Alright, now this, the 3 dx, matches the 3 dx exactly. So I can rewrite this whole thing in terms of u and only u. And I will get now the integral of the sine of the u du. Alright, I want to take the integral of that. That's a fairly straightforward one. That is negative cosine, right? Negative cosine u plus c. Derivative of negative cosine would be positive sine, so that's right. And now I back substitute negative cosine of 3x minus 1. C goes away, and there it is. Take a quick derivative of that, right, to make sure that I'm right. And the derivative of cosine is negative sine, therefore the derivative of negative cosine is positive sine. 3x minus 1 multiplied by the derivative of what's inside. This is trigonometric chain rule, right? Multiplied by 3, and then I can tell right now that that matches my original problem. So this answer that I got is correct. Next one, number 3 is actually a little more challenging. So hopefully you pause it and tried it already. There's something different in this one that hasn't come up yet. 4x plus 10 to the 5th dx. I don't want to expand this thing 5 times and take a bunch of, do a bunch of distributions and then power properties. So I'm going to use trigonometric substitution. So trigonometric u substitution, not trigonometric. And I don't have really like a second part to this thing where I'm looking for 1 degree higher, but I do know if that were my u and I take the derivative of it, I won't have an x anymore, and that's good. So ultimately I'm going to make my u equal to 4x plus 10. I'm going to take the derivative of this with respect to x, I get 4. And now I rearrange that, and I go du equals 4 dx. Now, what I've got is it's not exactly like all the rest of these that I'm working on. I'm going to get rid of that for a second. It doesn't match exactly. But the dx part, right, I've just got an extra 4 right here. So I'm going to move that, with algebra over to the other side of this thing. So ultimately, I will have du over 4 equals dx, or maybe, sorry, I should call it 1/4 du equals dx. Now I can rewrite that whole purple integral in terms of just u. That would become, blue for fun, 1/4 now, the integral of u to the 5th du. I can see that everything matches. I've got 1/4 du is dx, so there's my dx, and my 1/4 du is written, there and at the end. And I also have u, which is this guy, but it's raised to the 5th. Now that blue integral over there is really easy. I take the integral out, just my 1/4 stays outside. The u to the 5th becomes u to the 6th over 6. And now this just becomes, I'm going to back substitute and multiply at once. So I'm going to have 4x plus 10 all to the 6th over 24. That should be plus c here, and plus c. And that is my final answer. You should take the derivative of that just to make sure that it matches up and you get back to the original integrand. See if you have the right answer.